Chances are you're currently using air power to operate various pneumatic tools within your facility. Air power has been a mainstay of industrial applications for the past 2 centuries. And it has many benefits, including it's most likely already installed and it's easy to connect to existing air lines. Basically, you're using air because it's there and it's what you're used to. But do you know how inefficient and costly it is for operating pneumatic tools? Let's take a closer look. This typical 100 horsepower air compressor consumes 100 kilowatts of electricity between the motors, controls, and integration. The air compressor must convert that electric energy into mechanical energy. This mechanical loss includes energy lost in gearboxes, belts, and couplings. Air compression requires energy. Any unused energy is converted to heat that must be expelled to prevent the compressor from overheating, which is one of the largest maintenance costs of an air compressor. We are now only left with 10 to 15 horsepower of useful output energy. Unfortunately, about half of the remaining 15% is lost to air leaks and inefficient piping. That means only 5 to 8 horsepower of input electrical energy is actually being used to power your equipment. You may think, I'll just get a larger air compressor to get more output. Unfortunately, bigger is not better when it comes to air compressors. As a general rule of thumb, a compressor that runs at 50% capacity consumes 20% more power than a compressor running at or close to full capacity. Therefore, air compressors that are too large for the facility's air requirement actually waste more energy. So, that's the quick and dirty on how inefficient air compressors are. Now let's talk about how much compressed air really costs. Let's say this air compressor operates for 5,000 hours per year at a usage rate of 0.7456 kilowatts. At a power rate of 5 cents per kilowatt hour, when we do the math, we are spending about $14,000 in energy each year. As long as we're doing the math, we should also factor in annual maintenance costs, which is typically 10% of the purchase price. That's almost $60,000 in your first year of operation and close to $20,000 a year to operate it. Wow! Have you considered that in general, electric motors and pumps can cost 75 to 80% less to operate? You may find that hard to believe, but let's do the math and see what we come up with. For the sake of this video, we'll compare 2 high-quality Graco pumps. Here we have the data calculations for a range of pressures. Let's take a closer look at the cost of the kilowatts per hour for both pumps. As you can see, the cost difference ranges from 76% less to 81% less. That's quite a cost savings. What's even better is that the average cost to install an electric drop is about the same and sometimes even less than installing an air drop. That being said, typically a single new air drop for a new air pump runs about $700 if installed in-house and $1,800 to $2,000 if installed by a contractor. Modifying an existing airline is typically 25 to 50% of the cost of a new airline. Compare those costs to the costs of installing a single new electric drop for an electric pump. While air power has been around for 2 centuries, it's clear there's a high price associated with operating air compressors to power pneumatic motors and pumps. So why not save money and increase your efficiency while still enjoying the benefits of an AODD pump by installing an electric version?